Hello everyone and welcome back. This is Dan and we're continuing the inverse function series. This time we're looking at quadratic functions. So in this example, we want to find the inverse of the function f of x equals 2x squared. So first step is to write this as y equals 2x squared. Our second step is to swap our x and y's. So we have x equals 2y squared. Now we can solve for a y by dividing by the coefficient, and we get y squared equals x over 2, and then we take the square root. So we have y equals the square root of x over 2. And that seems like it should be fine, so let us graph this. So our first function was f of x equals 2x squared. So that means at 0 it'd start there, and at 1 we'd go up to 2, and then you just need to graph like this. And then for our inverse function, we had the square root of x over 2. So for this, that means that we're coming over here and over there. Let's give this a new color. And this would go kind of like this. But now we have to ask ourselves, does this seem right? Because to me it doesn't. Let's do our vertical line test and find out. So as we go along, we ran into an issue. See how it hit that red line twice? And again? This means this is not a function. So what do we have to do? Well, let's start over. So we have our f of x equals 2x squared. And if you remember, what we can do is we can restrict the domain of our original function because that will restrict the range of our inverse function. So here, if we say x is greater than or equal to 0, now we can do this. Now we can say, okay, y equals 2x squared. And from here, we are going to swap our x's and our y's. And then we're going to try to solve for our y. So we're going to divide by the coefficient. We get y squared equals x over 2. We're going to take the square root again. And now we have y equals the square root of x over 2. But we are only looking at it when x is greater than or equal to 0. So this is only when it's positive. So now we can graph this. So for our original function, we're only looking at it when it is on, or when x is greater than or equal to 0. So that means we're going to be here, and at 1 we go up to 2, and it goes like that. Then for our inverse function, remember the domain and the range switch. So now we're going to have y is greater than or equal to 0. So here we are going to start right there and then over at this point there, and we go like this. So now what is our domain and range? So our domain for our inverse function is x is greater than or equal to 0, and our range for our original function is y is greater than or equal to 0. And you can see that these two are linked. So this is how you do an inverse function for your quadratics. If you get to a point where it looks like it can't be a function like we had before, then you need to restrict the domain. And if you restrict the domain of your original function, it'll restrict the range of your inverse function, and you should be fine from that point forward. If you guys have any questions, don't hesitate to use the Ask a Tutor function or ask us in a live lesson. But I will catch you guys next time. Bye.